Okay, so in this video, we're going to talk about analysis of variance. And for that, we need to make an analysis of variance model. Friendly reminder that ANOVA testing, so analysis of variance, another word for that is ANOVA. If I could ever type correctly, that'd be great. What that does is that compares the means of two groups. So we're looking for variation among the sample means divided by variation among the individuals of the sample to see if that is significant. So our null hypothesis is that all means are equal, and our alternate hypothesis is that at least one mean is different. Okay, and so for this I want to use the MT-CARS data set real quick for us to set this up. MT-CARS is a data set built into R, so there's nothing to download. All right, so here's our MT-CARS data set. It's broken down into cylinder, mile per gallon. This is engine shape, whether it's an automatic, yes or no. So I'm going to create an ANOVA model, and I want to look at miles per gallon by cylinder. So like, is there a difference in the miles per gallon, the average mile per gallon, depending upon what the cylinder is? So to make an ANOVA model, we're going to use the code AOV, and let's question mark that. So here's how we would fit an analysis of variance model. So you're going to have to put in a formula. So for us, our formula is going to be the miles per gallon. Is that affected by a cylinder, right? So we're going to do miles per gallon by cylinder. We do our dependent variable first, and then our independent variable second. And I have to define my data set. So my data is MT-CARS. There's a lot of other things we can put in. We could do a logic flags, list of contrast, but this is the most simple analysis of variance that we could run. Okay, so we get to run this. And then I want to do the summary of this. So why don't we go ahead and give it a name? This just makes the model, but if I give it a name, then I can call it later. So we give something a name with an arrow. I'm going to call it one way miles per gallon by cylinder. You can call it whatever you want. And then I can get a summary of this data set. Not of this data set, of this model. So I'll type one way by MPG. All right. So here I have my degrees of freedom, the sum of squares, the mean value, my F statistic, that's what you get. But what I care most about is this probability. This probability is really, really low, right? It's practically zero. So yes, that means there is a difference. There is a difference in the mean miles per gallon based on cylinder, right? If there hadn't have been, then we'd have a really high p-value down here. Let's make another model. I'm going to make another model. This is going to be one way miles per gallon by weight. Does weight have an impact on miles per gallon? So I'm going to do miles per gallon tilde weight, which is WT in this data set, right? My data set is still MT-CARS. You should probably put an equal sign in there so this actually runs. And then I could get a summary. I can also do summary.AOV. It's going to give you the same output as it would have before. So here I have my miles per gallon by weight. Error, one way mile per gallon by weight, not found. I didn't call this an analysis of variance model. That's why we were having the issue. Now I have my model and I have a really low probability. So this means it appears weight does have an impact on miles per gallon. There is a difference in the mean miles per gallon based on a car's weight. Okay, so those are one-way ANOVAs. I could do a two-way ANOVA. I want to look at the impact of cylinder and weight on my car. So I'm going to call this two-way on my miles per gallon. I make an analysis of variance model. I'm going to do MPG tilde weight plus cylinder to look at them both. My data set is still empty cars. And let's get the summary of 2 dot way. It should have generated. All right, so here's my summary. It's a very high significance level. So there is a difference in miles per gallon based on cars and their weight, right?